Okay, so today I'm going to be going over an 820-2610 motherboard that's not turning on. We're going to start with how we troubleshoot, why we go through the steps that we go through, and what leads us to our conclusion to how to fix it. And all of this is going to be done in real time, like with all of these videos. So this is a 2009 17-inch unibody. The reason I enjoy bringing this board up is because often when I get trolled by people who say, Apple products don't have problems for every year, you're making this stuff up. And I bring up the recalls, very often they'll say, what about 2008? What about 2009? Those are solid models, right? Wrong! And you're going to see exactly why in this video. So this doesn't turn on and it has no liquid damage. So if I am to plug the MagSafe in, I get a nice light. See, I get a light. And when I short the power pads here, it doesn't turn on. So in a no power issue, the first thing that I'm going to want to do is check each one of my power rails. So what I do here is I open the schematic and I'm going to go to a page on the schematic that shows me this stuff. So let's just open up the open broadcaster monitor on the other screen so I can see what I'm showing you. The first thing that I'm going to check for is PP Bus G3 Hot, which is an always present rail. So I'm going to check PP Bus G3 Hot over here. And let's see if I can set this up so that you can see the multimeter along with the screen. Here we go. So I have my multimeter right here. You probably won't be able to see that because it's too damn small. But we're going to check PP Bus G3 Hot on the sections that it says it's supposed to show up. Now the schematic says it's supposed to be 6 volts, which I think is wrong. I think it's actually supposed to be 8.4 on this one. And it's 8.39. So I ignore the schematic. The schematic in this case is wrong. PP Bus G3 Hot is supposed to be 8.4 volts on this board. I know that from testing working boards. So it's really important if you want to do something like this for a living that you have known working devices so that when the schematic is wrong or when you're confused about something that the schematic says, that you can clarify that information. So what we're going to do right now is move on to the next voltage rail, which is this PP Bus, CPU, IMVP, blah, blah, blah. We are going to check to see if that exists. So we check to see if this exists. Not found. Sometimes the stuff is named differently in the schematic than it is in the board view software, which is a complete pain in the ass. All right, so we're going to check on this side of the board where it says that I'm supposed to check. I get 8.39. Now we move on to the next one. Now, PP18V5 DCN connection. I know that I can ignore that one. And the reason I know I can ignore that one is because everything else in the machine wouldn't work if the charger rail wasn't present. So PP18V5 DC-in connector. I'm adding some words in there. So I'm just seeing con, and I'm assuming that means connector. This is coming in. That was loud. This is coming in from the charging. So this is going to be coming in from the charger. So I have no interest in checking that if my other rails are present. If the charger rail wasn't present, PP Bus G3 Hot would not be present. Therefore, I can save time by just not checking that power rail. Now, let's move on to the next one. The next one here is PP3V42_G3 Hot. Now, I know that that rail is present because that rail needs to be present in order for the one-wire circuit to operate. If you don't know what the one-wire circuit is, I would highly suggest that you check out my other videos in this channel related to the one-wire circuit. Long story short, the one-wire circuit is what allows the charger to talk to the system management controller chip on the motherboard. If the charger cannot talk to the system manager controller chip, you won't get a green light in the charger. And because I have a green light on the charger, I know that my SMC is on, so I know that PP3V42 must be present. So what I can do at this point is move on to the next rail, which is PP5VS3. So I'm going to check and see where that rail is and where I can measure it on the motherboard. Let's see if I can measure it here. All right, so I'm going to check for it. And where it says that I'm supposed to see that, let's see, where is that on this board? Too big. I should just check it on the other side. I never bother taking the speaker off, which makes it a little bit more difficult. Let's see. A nice big place to check for it is right here. There we go. This thing always knows which way it is on the desk so that it can put it the opposite way. and we have 0.000 volts. Now we're on to something. So now let's continue following along this path and see if we can understand what's going on. So what I'm going to do at this point is I'm going to see if PP5E S3 is being told to turn on. Now, what I've been saying in this video series for a while now is that I like to check the beginning of the circuit and the end of a circuit so that I avoid wasting time on everything that's going on in between. So the way that I like to save time, I check the end of the circuit, meaning PP5ES3 is not there. Now, instead of going back to see what creates PP5ES3 and blah, 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 I'm going to go back to the enable signal that tells it to turn on. So let's go over the PP5ES3 circuit in the schematic here. I'm just looking for where it shows up. It shows up everywhere, but I want the page that actually creates it. And here we are. So let's full screen this so that you can see it a little better. And let's get my ugly face out of the way. Ah, that's more of my ugly face in the way. Okay, so we are, let's see, where was I here? Here. All right. Now, this seems very, very confusing. Very confusing, right? Let's try to make this a little less confusing. What do you think here is going to turn on or enable my chip? Maybe it's one of those pads that says EN for enable. You're going to notice that a lot of what you're doing here, a lot of your job is just, when you're doing this type of thing, it's just adding vowels and consonants onto words that are very hyper-abbreviated. Now, where is PP5ES3? PP5ES3, it's here. It says 5 volt, 3.3 volt power supply. And over here at the end, you can see PP5ES3_reg. That is the rail that is missing. So it's created by the left side. Now, this is a buck converter. If you don't understand what a buck converter is or how it works, again, I have a video in the Basic Electronics video series that tells you exactly how a buck converter works, what it is. I show you with pictures. I represent what's going on at every single individual point. If you don't know what a buck converter is, I would suggest you pause this video at this time and move on to the video where I explain what a buck converter is. If you don't know what is enabling PP5ES3, what you can do is you can take the name of the chip, which is included right over here, and I can Google that, and let's see if we can get a data sheet for the chip. So here we go. We're getting a data sheet. So now, I'm not interested in most of this. What I'm interested in is the pinout, where it's going to tell me what each individual pin does. I don't care about this whole operating temperature and all of this engineering mumbo-jumbo. That's not for us. That's for designers. I'm interested in is this. Okay, what pin does what? What pin does what? There we go. EN1 and EN2. Channel 1 and Channel 2 switched mode power supply enable pins, because that is what a buck converter is, a switched mode power supply. When turning on, apply greater than 0.5 volts and less than 6 volts to connect to ground to disable. So EN1 and EN2. Let's go back to my schematic over here. Now, on the right, you see EN1, and that's on the side of PP3V3. On the left, you see On the right, you see EN2, which is on the side of PP3V3. On the left, you see EN1, which is on the side for PP5V. Which enable do you think is the one that we're looking for? Do you think this is channel 1, or do you think that this is channel 1? I'm pretty sure that the left side is channel 1, because the left enable is on the left side, which is where PP5ES3 is. So EN1 is probably what I'm looking for. So let's follow this line a little bit and see where this is coming from. Now, unfortunately, during 2008 and a little bit of early 2009, the schematics were written by people who were, kind of high on marijuana. So you could see that they decided, instead of drawing a line, that they just decided to draw a box. Like, this is some kind of, hippie existentialist movement, or, yeah, man, why is a signal gotta, go to places, man? Why can't it just circle around and become one with itself? No. I know this is fucking confusing. I'm sorry on behalf of whatever hippie Apple engineer was roasted the day that they decided to do this. But here, see where it says in? This is the signal that is going to enable 1. I know it's hard to fucking tell, but in the other schematics it's not, because they didn't have crackheads doing it that day. P5VS3EN. Remember what I said. To save time, I don't check every single thing along the way. I check the front of the circuit and the back of the circuit. So I've already checked over here. I don't have 5 volts. I'm not going to check this now. I want to see where this shit comes from, because I don't want to waste my time on everything in between. I'm not going to waste my time checking that. I'm not going to waste my time checking this resistor. Let's see. Now, I'm going to try to figure out where this ends. So PM sleep S4L is going to create that through this resistor. I'm not even going to check that resistor yet. I'm not going to check this signal. I'm going to check where this begins. We've checked the end. Ow. Lower the volume, for fuck's sake. So PM sleep S4L. That comes from MCP79, which is the big chip in the center of the motherboard, which must mean that that chip is dead, right? I need to reball it. I need to replace it. I need to reflow it with a heat gun, like they tell me on all these dumbass websites, because that chip on this board is also the GPU, and all these people, they put towels on it, and they fix it with towels or with heat guns, because that's or ovens and reflow ovens. And this is where you guys... You got to stop that shit, because you're giving our industry a reputation as people who don't have a brain, who can't think. And it's just very, very bad. The way I actually wound up figuring out what's really wrong with this board is I thought it was a BIOS issue, because the BIOS controls the MCP79, or in this case, board, the SPI ROM. So I would replace BIOS, and it would work, but then it would stop working. It would work, and then it would stop working. And the BIOS is right over here. The problem with this board is right over here. So what I was actually doing is I was heating the section, heating around the section with the problem, and the component that was dead would come back to life for a second. And I'm going to show you how we figure out what component that is. So MCP79 is not putting out a signal that it's supposed to put out. So let's see something here. So instead of assuming that the MCP is dead, how about we check and see if the MCP actually has power to turn on? So we're going to go back to that page that lists all the power rails inside the machine. And let's see. What here is probably going to the MCP? So we're not making it to an S3 state. We're not making it to an S3 state. So I'm not going to check the SO rails. I know they're not there because we're not even in S3. I'm not going to check this at the moment, not this at the moment. So we go down the list of rails, and we're going to get to one that is interesting because it's one that's responsible for the MCP to be working. PP1V05 S5 MCP, right? This rail, this thing right here. This is also a buck converter. So let's see what we have here. So this is going to be 1.05 volts that goes to the MCP. And we can check that right over here around this coil. L7770. Now let's see what happens on the multimeter. Voltage mode, we get this back on. .315 volts. Now that doesn't seem like 1.05 volts to me. Now if you take a look at that area, let's think about this logically. Let's think about what is likely to go wrong when there's no liquid damage on the board, when there's no signs of overheating, because keep in mind, this is a machine that actually runs pretty cool. The graphics card that comes with it is not the way too powerful, way too hot for the cooling system that Apple's used to putting in these machines. It's something that's actually appropriate. So what in this area is going to go bad for no apparent reason, or what component has the reputation for going bad for no apparent reason? So if I switch over to the microscope camera and you look around, you can see there's no real liquid damage. There's no physical damage. There's no damage in terms of something exploding or a shock or overvoltage or anything like that. There's no evidence of any of that. But we do have a capacitor over here. And here's where I want to get into. I want to get into what Apple did wrong. So they ran out of space over here. They ran out of space. And what you may notice is that these over here, these 330 microfarad capacitors are large, whereas this one is tiny. Not only is this one tiny, but it's also really, really expensive. And that is an issue. So it increases the cost of the board, and it doesn't last as long. Now, one thing I want you to understand is that this is an S5 rail. So this being an S5 rail means that it's going to be on all the time. So that little cap is going to be working all the time. If the computer's plugged in, it'll be working. If the computer's not plugged in, but the battery is there, it will be working. Even if the battery is too low to provide power for the computer to turn on, that rail will still be working. So what? So PP bus G3 hot, instead of being 8.4 volts because the battery is dead, it's at 8 volts or 7.9. That buck converter is still going to be working. It may not be making 1.05 volts, it may be making 1.0403, but still, that thing is working all the time. So for something that's going to be working and on all the time, you're going to want to use a component that is going to be able to stand up to that level of abuse. Not one single little tantalum capacitor that is too small for the job at hand, that doesn't have anything in parallel to help it out. And that's the problem that we encounter here. And this is why a lot of the 2008 and 2009 unibody boards die a random death just out of nowhere. Again, no water, no drop, no over voltage, no knockoff charger. It just dies. And for all of you saying that there was no recall in 2008 and 2009, you are right. Apple didn't have a recall for unibodies in that year. Unlike, again, they had the 2007 and 8 pre-unibody recall. They had the 2010 graphics recall, 2011 graphics recall, 2012 graphics recall. Recently, the Mac Pro 2013 graphics recall. But this shit should have been a recall. This should have been an extended warranty. Now, I know what you're thinking. You may be looking at me and saying, Lewis, it's 2016. Of course, shit from 2008 is going to be fucking dead. The thing is, this shit was dying in 2010. This shit was dying in 2011. This was dying in 2012, 2013. It's been dying for a very long time. And Apple managed to weasel their way out of supporting their customers here. And if you look at, let's say, C9560 on the 820-2850 board, you may get some bit of understanding as to why that board has graphics chip issues. Tell me if anything looks similar to you. Tell me if anything looks familiar to you from what you see on this board. A lot of people on forums have been driving themselves crazy trying to figure this out. I know, Duco from Netherlands was one of them who just thought, he thought that these boards were all trash for a very long period of time. And he's very good at pattern recognition. He's amazing at pattern recognition. He's great at just general basic logic and common sense, and good at distilling this stuff down into common sense. And then one day he looks at this board, at that cap, and then he looks at the 2850 board and he sees that cap and he thinks to himself, wait a second. And bada bing, the 2850 boards are no longer useless crap. Pretty cool stuff. I actually hope to be opening a question and answer forum soon where you're going to have access to people like that who will be able to answer these questions to a high standard of quality for you. And that's something that I'm excited about. Hopefully that goes well. So back to what we were doing. So the proper thing to do here is to put a non-tantalum capacitor there so that this shit will actually work. And that's going to be the fun part, because we have to do a little bit of moving around, because the non-tantalum capacitor is going to be considerably larger in size, so fitting it into that space is going to be a bit of a mess. But so a little bit of relocating, nothing crazy. It's just a bit of just a bit of house cleaning. So let's see what we have to do here. First things first, these are large components on a multi-layer PCB, so I got to turn the temperature up a little bit here. Apple, by the way, never solved that problem. When they would fix those boards, they were still kernel panicking. So a lot of people will say, authorized repair is the only way to go. When Apple failed to figure out what was wrong with those boards, some random dude who fixes this stuff out of his home did. Just something to be thinking about if you're one of those trolls who always talks about an authorized repair, can't figure shit out. Again, an unauthorized person who does this as a hobby out of his house managed to figure out shit that Apple's entire engineering department looked over. Just something to think about here. Okay, now we're going to make some room. We made a little bit of room there. Now we're going to remove this capacitor. Okay, we take that out of the way. Let's get rid of some of that old lead-free solder. First thing I'm going to do here is add some leaded to make it easier to get rid of. My iron doesn't want to get hot. It's a lazy Sunday. Lazy Sunday here at work. One thing I love about this JBC is I can actually turn it off when I'm done and turn it back on. I don't like I like the HAKKO and I like the WHA 900, but the thing is it takes so long for that shit to heat up that you turn it on when you start your workday and you turn it off when you're done with your workday. Like that's really the way that works. You can't if you actually expect that you can turn that thing off and then turn it back on and have a productive workday, it's impossible. Because I like the Weller WHA 900, but the amount of time it takes to get the temperature is just absolutely ridiculous. I mean, maybe if you're working on stuff that doesn't really that doesn't require a high temperature, it's good. But if you're working on stuff like this, again, you're going to notice that thing takes forever. I got a little bit of dust on the board along with the flux. I guess I'll have to live with it. I also scraped very hard, and you may think that that's a bad thing that I shouldn't have done. Again, but you'll see. Like, again, what I'm going to be doing to this board to make it work is so ridiculous that what I did right here is really of no consequence in the greater scheme of things. Usually, you actually are scraping in order to fit the larger capacitor in. I'm doing my best to not heat up that dust and crap because I don't want it to get inside my solder joint. Get out of here. So now what I'm going to do is find myself a 330 microfarad capacitor that is not made of tantalum that I'm going to put in that space. And once I do that, this will be set and working. As soon as I find a board that actually has one left. Let's see. Ooh, I have one left in the spool. Beautiful. I have one left in the spool, and there's no need for theft. I've went through an entire spool of this already. This is so ghetto. Let's see, which way would this be better suited? Yeah, some shit like this. Let's move it out of the way of that coil. Yeah, I know what you're thinking. Unprofessional. You know what's unprofessional? Designing a board that's made to die. So don't give me that shit. If Apple gave me enough room on the circuit board, I would be more than happy to fix this quote-unquote properly. But they didn't. What do you want from me? Seriously. You want me to put another tantalum one on there that's going to die in a month? I often talk about reputation in this industry and, and doing things that are going to last and doing things that you can actually feel good about. I want the shit that I do has to actually work. It has to last. And I talk about decreased consumer confidence in repair because you have a lot of idiots that go around, doing stupid shit like reflowing graphics chips and blah and giving it back to people with a 30-day warranty and it dying and, that's going to make people less likely to fix stuff. I'm not going to put a tantalum one there just because it looks nice. It's going to die. Yeah, I can actually get a better fit if I just... It's the first thing to do here. I had a... if you really wanted to get into the professionalism of what I'm doing, technically, yeah, this is probably less structurally sound in terms of if you dropped it from the top of a building, like would it still work, kind of thing, because you know the component is too big for the pads, and over here I have the coil that's soldered to, let's say, half of the pad. So you're right there, but at the same time, you know, it's compromise. Like, if somebody drops this off of the top of a building, it's going to be dead anyway. So it might as well have it so that for the people who don't decide to drop it off the top of a building, it will actually work. All right, so first things first here. We're gonna put that coil back on. But first, I want to make sure that the capacitor had a solder ball growing on the side of it that I wasn't fond of. The reason I'm redoing that is because what I'm doing here is, like, with the... What was I saying? Because there was a solder ball right on the side of the capacitor that I couldn't get to. But also, again, if I'm going to have the coil soldered to half of the pads, at the very least, it would be nice if I could do that with, a fresh solder joint instead of a 7-year-old solder joint that I just semi-reflowed with no flux. Yeah, I could definitely move that over a little bit. Okay, now that that is done, now I'm just going to move the capacitor up a tiny bit. Get it right where I want it. So there you have it. Nice crooked board. Everything that I do is crooked, so I mean, like, in terms of, aligning stuff, it's almost kind of like my warranty sticker at this point. So I'm okay with that. Okay, we swing this back into place. If you're thinking of getting the articulating stand, do realize that it moves around constantly when you have your... If somebody's walking down the room, down the hall, you're going to have it shake all the time. The articulating boom stand drives me nuts. So what I do is I have the non-articulating one, but I just keep the knob semi-loose, and I can just swing it to the side and push it out of my way. I strongly recommend not getting the articulating boom because it'll drive you nuts. Watching Mark Schaefer try to do long screw at Practical Board Repair School with that articulating microscope is the funniest shit. Okay, so let's see what I get now on the multimeter. So I'm going to move it back to voltage mode. I had it in ohms just so that I could see. There were three pads on that capacitor, and I just wanted to see which ones were the same, so I wouldn't short my circuit to ground. 1.101. It's not 1.05, but it's definitely closer to 1.05 than 0.316s. All right, so now if I short the power pads on that same board, what do you know? The fan spins, which, as I like to joke on this channel, means that I'm done. Totally done. So, yeah, that's that. And I hope you learned something. You can join the forum. That's going to be in the link in the description. It's going to be a $30 a month membership if you would like to be able to ask questions on this stuff and get answers from people with equal or more knowledge than myself. We also teach an in-person tutoring class at the store where we go over this stuff one-on-one. So if you want to learn more about motherboard repair and you're not really getting what you need to get out of the videos, you can come here. I'm going to have a link to that as well. And if you don't want to spend a dime, you would rather die than see me get like a nickel of your money, then you can watch these videos, which are completely free. I have over 100 videos and instructional content on component level motherboard repair, and it's all free so that you can learn how to do this stuff, and hope you learned something.